3 episodes of Python RAG, FastAPI, BM25 sparse vectors, cross-encoder reranking, FastAPI service. That is the Qdrant Hybrid Search series, and if you have not watched it, the link is below in the description, and there is a setup script in the GitHub branch for this episode. Today, we make the same products collection we built in that series, and we connect it to the Slack agent from episode 2 in n8n without rewriting retrieval code. The Qdrant Vector Store node handles the query. A 3-node sub-workflow wraps it as an agent tool. By the end of this episode, the agent can search the knowledge base, site source by product ID, and route between web search and product search based on context. Every file is importable from GitHub, and let me start with the architecture right now. Let me show you the bridge between the two series. On the left hand side, the Qdrant Hybrid Search series, 3 episodes. Episode 1 covered why hybrid search, the failure modes of dance only, and how BM25 catches exact identifier queries, how RRF Fusion combines the 2 rank list, and episode 2 was the Python implementation, like fast embedded for BM25, sparse vectors, the prefetch API, 500 product records indexed. Episode 3 was the production FastAPI service, cross-encoder ranking, latency tracking, the full retrieval pipeline. At the bottom of the left column, the products collection in Qdrant. 500 records, dense vectors for semantic similarity, sparse vectors for keyword precision, both indexed and ready. On the right today, we do not reindexing again. We do not rewrite the retrieval logic. We point the Qdrant Vector Store node at the same collection and wrap it as an agent tool. 3 nodes, 30 minutes. If you already have the collection running from the Qdrant series, import the workflow JSON and agent is live. If you do not have the collection, the GitHub branch for this episode has a setup script that indexes the 500 products from scratch. Either path the episode works. Let me switch back to the Visual Studio, and in the VS Code Explorer we can see the episode 3 RAG pipeline here. In the workflows folder, we have every JSON we need to import the n8n. So this is the companion repo for the Qdrant Hybrid Search lab. Here is the full architecture with the new RAG tool added. You are looking at the episode 2 agent with one addition, the select trigger. The React agent, Redis chat memory, the 3 existing tools are unchanged. The new piece is search products on the right. When the user message is product related, the agent routes to the search products. The sub-workflow embeds the queries Qdrant, formats the results with metadata, and returns them. The agent synthesizes an answer and cites the product IDs in its response. The agent decides when to call search products versus search web-based on the tool description. Product queries go to Qdrant. News, reviews, live data goes to Brave Search. They are not mutually exclusive. The agent can call both in the same reasoning loop if the query warrants it. Let's go back to the Visual Studio. Now let's focus on the tool search product JSON. So with this JSON, you can import everything to n8n Studio that I talked about. So the search products sub workflow is here. Let's build the ingestion pipeline first, then the retrieval tool. Before the agent can search the knowledge base has an exit in Qdrant. If you have the collection from the Qdrant series already, skip this slide. Your collection is ready. If you are starting fresh, create a new workflow for ingestion. This runs once, or on a schedule if your product catalog changes. The pipeline is 5 nodes. A manual trigger or schedule trigger at the top, and HTTP request node or read binary files node to load your documents, especially in your case a JSON file of 500 products, a recursive character tag splitter node, chunk size 500 characters, overlap 50, splits on a paragraph, then sentence, then word boundary. Next, an embedding node. I'm using OpenAI text embedding 3 small here. 384 dimensions. This is the same embedding model the retrieval query will use. For example, they have to match, or the similarity scores are meaningless. Finally, a Qdrant Vector Store node in insert mode, like collection name, products, host on the localhost, or your Qdrant URL. Metadata fields to store, like name, category, price, and ID. These come back with every result, and the agent uses them for citations. Run this once. Open the Qdrant collections at the localhost /dashboard. Confirm the products collection has 500 points, and you are ready to build the retrieval tool now. Let's check the ingestion pipeline. It's here. So you can import this to n8n very easily. So if your collection already exists, briefly, Qdrant dashboard will skip reindexing. Now the retrieval side. 3 nodes, 1 sub workflow. Create a new sub workflow. Add a when executed by another workflow trigger node, same as the other tool sub workflows. This receives the JSON object the agent sends, a query string, and an optional category filter. An embeddings node, same model as ingestion, text embedding tree small, and set the input to do JSON.query. This converts the query string into a vector. Add a Qdrant Vector Store node in get many mode. Point it to your Qdrant instance, like collection products, top key 5. Enable include metadata, and the credentials go in the n8n vault, the hostname and the API key. If you are using Qdrant Cloud, you should use that. If the agent passes a category and a filter, the Qdrant node supports payload filters in must format, like the fields with category match value with JSON.category. This scopes the search to one product category when the user asks something like noise cancelling headphones. At that moment, you get 5 headphone results instead of 5 results mixed across categories. Top key 5 is usually right for an agent tool. You want enough results to synthesize a good answer, but not so many that you are paying for tokens on irrelevant context. 5 is default I use. So if you go back that, look, there are nodes. Start, embedded query, Qdrant search, and the format. Everything defined in this JSON. And the top key filter will act on it. One important caveat before we move on. I want to be direct about what this Qdrant Vector Store node is and is not doing. It is doing dense vector search. That means semantic similarity. If the user asks noise cancelling headphones for travel, the embedding model finds results that are semantically close to that query. This works well for natural language queries. What it is not doing is BM25 sparse vector search. The hybrid RRF fusion from the Qdrant series, the thing that handles exact identifier queries like model numbers and SQs. That requires the preferred API with 2 separate queries, which the n8n Qdrant node does not expose. So if a user asks, tell me about the Sony VH10000XM5, the dance only mode will probably find it, the embedding for the sentence does cluster near Sony headphone content, but it is less reliable than the hybrid approach for precise identifier matches. The honest answer is dance only is the right default for most knowledge-based use cases. It covers the 19% case in 30 minutes with 0 Python. If you need the full hybrid pipeline, and the Qdrant series is exactly that pipeline, you replace the Qdrant Vector Store node with an HTTP request node pointing at the FastAPI service from the Qdrant series episode 3, same sub-workflow structure, same workflow node wrapping it, different internals. I am going to show both approaches. We use native node in this episode. The HTTP request pattern is in the GitHub branch as a bonus sub-workflow. Back to the build. The third node in the sub-workflow is a code node format up. The Qdrant Vector Store node returns a row array of matched points. Each point has a score and a payload with the metadata fields you stored at ingestion. The agent cannot use that row structure directly. It needs a clean, readable array. Add a code node after the Qdrant node. The transform is straightforward. Map over the results, pull out ID, name, category and price, and the description of course, from the payload, and return the array. 6 lines of JavaScript. Here is the critical thing about the tool sub-workflow outputs. Return exactly what the agent needs to form a good response. Too little, and the agent hallucinates to fill the gaps. Too much, you waste tokens on fields the agent ignores. For a product search tool, name, price, category, a short description snippet, and the product ID for citation. This is the complete set. No more, no less. Now go back to the main agent flow. Add a workflow tool node. Set it to call the search product sub-workflow. Fill in the name. Search products. Exact match to the sub-workflow name. The description is routing signals the agent uses. Like search the product knowledge base for product information, specs, prices, and availability. Use when the user asks about the specific product or product category. That's it. Input schema like query as a required string, category as an optional string with enum of your category values. Like it can be smartphones, laptops, headphones, whatever your catalog has. The enum matters because it helps the agent pass a valid filter value instead of guessing. Connect the workflow tool node to the agent's tools input. The agent now has approximately 4 tools. Exactly 4 tools. Now check out the agent with rack JSON from the Visual Studio. As you can see, we have the nodes of Slack trigger, AI agent, tool search products, which the magic happens here. So then the reply. All is compacted here and ready to import to n8n canvas. Let me show what the agent's response look like with source citations. Source citation is not a separate feature you configure. It's an emergent behavior of the system prompt and the tool output structure. Here is how it works. The agent calls search products with the query noise cancelling headphones under $300. The tool returns 5 results, each with an ID field. I include in the system prompt a single instruction. When citing products from a knowledge base, include the product ID in square brackets as a reference. Watch the agent response in execution log. Based on our product catalog, here are noise cancelling headphones under $300. Bose QC45 at $279. Balanced noise cancellation with 24-hour battery. Reference ID 108. Anchor Q45 at $79. Budget option with excellent 40-hour battery life. Reference ID 115. And the last one, the Sony VH10000 XM5 is slightly above your budget at $349, but it's top performer if you can stretch it. So has a reference ID too. Every claim is traceable back to specific record in the Qdrant collection. If a client asks why the agent said something, you open the products collection, query by ID, and you see exactly which record drove that claim. This is why citation pattern matters for regulated or enterprise use cases. You have an audit trail at the document level, not just the execution level. Now let me run end-to-end demo so you can see the full flow in the execution log. I'm going to send a message to the Slack channel, which I already did. Find me the best laptop for video editing. Watch the execution log now. Slack triggers fires at 0 millisecond. The React agent starts its first reasoning step. True, the user is asking about a product category. I should search the product knowledge base. It decides to call search products with query like laptop video editing and category laptops. That's it. The retrieval sub workflow executes and the embeddings node converts the query string into a vector, about 15 milliseconds. The Qdrant Vector Store node queries the collection, about 180 milliseconds, it's done. The code node formats the 5 result, total sub workflow time is around 200 milliseconds. Back in the agent, second reasoning step, thought I have 5 laptops with specs and prices. I can synthesize an answer. It calls final answer and constructs the response with product citations, and Slack reply fires. Total elapsed approximately 350 milliseconds. Compare this to the web search flow from episode 2 at 1200 milliseconds. Rack from a local Qdrant instance is significantly faster than a live web search API, and the results are scoped to your actual product category. No hallucination from the web results, no off-brand products, no outdated pricing. Let me wrap up with what we built and what episode 4 covers. We connected the Qdrant products collection from the Hybrid Search series to the n8n agent from episode 2. 3 nodes in a sub-workflow. 1 workflow tool node to wire it to the agent, and source citation as an emergent system prompt behavior. The dance-only trade-off is real. I showed you the HTTP request alternative for when you need the full hybrid pipeline. Both paths are in the GitHub repo. It's below, it's in the description. Episode 4 is the production episode. Everything we have built in these episodes 2 and 3 runs on Docker desktop on your laptop. That is not what a client gets. Episode 4 moves the entire stack to a VPS with SSL via Caddy. It's a second specialist agent using the multi-agent skill router pattern. Hardens the human in the loop gates and walks through the 5-point governance checklist I hand to clients on every n8n delivery. That is the episode that turns this from a demo into a billable system. So if you like this video and if you want this coming up, so please like it and see you in episode 4.